All right, so in the first, what letter are we solving for? N. So I know that your first instinct would be to distribute, but I would not. Since it's already a positive n and it's already a 1n, I would leave it as it is. But in order to do something with it, I need to get n minus 2 by itself. So what is happening to n minus 2? What is that 180 doing? It's being multiplied. Okay, so what's the opposite of multiplying by 180? Dividing. So I'm going to divide both sides by 180. So S over 180 equals n minus 2. So I drop the parentheses because I have nothing else on that side besides n minus 2. So then what do I need to do to get n by itself? Add 2. So I have n on the right, and on the left, I can't actually combine these. Can anybody guess why? Because of what? Yeah, because of the s. So I have a variable in this s over 180. So I'm just going to write them next to each other. So I'll say s over 180 plus 2. That's it. Number 2, I equals PRT. This is actually an interest formula. Interest equals principal times rate times time. We're going to solve for R. What is happening to R on the right side? It's being multiplied by P and T. All right, so what's the opposite of multiplying by P and T? Dividing by P and T. So on the left, it looks like I divided by P, T, and on the right, all we have left is R. You can go ahead and put this away and take out the notes for today. You'll need 4 highlighters. So if you have only 2, I hope that the person next to you has other highlighters you can share. Alright, so we're going to talk about pairs of lines and angles. So 3.1 will be very similar to 3.2, and that will be very similar to 3.3. And then eventually you're going to have a project over this. You're going to do it in class. It's a very artsy project, but we'll talk about it when we get there. So first thing we're going to talk about are parallel lines. Okay, so parallel lines are coplanar lines that do not intersect. So that's the first term. Parallel lines are coplanar lines that do not intersect. After this slide, I'll show you a map, and we'll find parallel streets. So parallel lines are coplanar lines that do not intersect. So we learned in the last chapter, what kind of angle does this look like? A right angle, okay? Can I just say that it's a right angle? Is there proof that there's a right angle? No. So what would have to be there in order for me to know that it's a right angle? The right angle symbol. So the same thing is going to happen for parallel lines. You cannot say, well, it looks parallel, so they have to be parallel. What will pop up, so you want to draw these on yours, you're going to have little arrows like this. So go ahead and draw them on yours. You have the same pictures as I do. So one little arrow, little arrow. The other thing you might see a lot, in your textbook especially, you actually would see red triangles. They also mean parallel. So you'll either see a triangle or you'll see the arrows. Someone in my earlier class asked why these had 2 arrows, and I'll show you why. Okay, so I just drew some in just to kind of give you an idea. Which of these lines would XY be parallel to, if you had to guess? EF, why would you guess that? Because it only has one arrow. So in order to know these AB and CD are parallel, that's why there's two. Okay? So most of the time, however, you'll see either one arrow or you'll see these triangles especially. Okay? So there is a symbol for parallel. So you're going to write that in for the symbol. It looks like two straight lines. It is right here. Okay, I actually call them the Twin Towers, not in a disrespectful way in any way. Just, they're two long straight lines, so I would draw that in for the parallel line symbol. So we're going to list that these lines are parallel. We'll start with these two. How would I name this first line? Line L. Just go ahead and write it in with me. So I want to say line L is parallel to, what would I name the second line? Line M. Good. Could I say L with arrows above? Is that a thing? It is not. What would I need in order to use the arrows? So, you can't name a line like this. When is the only time you can use the arrows above? What would you need under it? 2 points. Good. So we're going to name these two. So you should be writing this in. Hopefully you wrote that in under. We're going to write in this one as well, because you're going to be asked to make those statements. I want to name these two parallel. How can I name my first line? AB with my lines above. So AB is parallel to CD. All right, so we're going to look at a map. This is a map of where we are. We are at this dot. We got I-10, you got 295. Normandy is down here. We got Crystal Springs. Okay, so looking for parallel lines, I can give you an example of what you would do. You would tell me the street names. So, like Cox Road and Perkins Place. They are parallel. Okay, are they the same length? No, but that doesn't mean they're not parallel. They still are parallel. So can anybody find two streets that are parallel to each other? What do you think?
Ramona Boulevard and Gordian.
Yep. All right, so Ramona and Gordian, or Gordian, that's the first time I heard it like that. That might be right. There's Ingram also is parallel with all three of those. What else is parallel to Ramona? Burma. Oh, yep. What about I-10? Looks pretty parallel. Do we see any others? There are a lot.
If I say Stewart, yeah, Stewart Avenue.
Stewart, you have to tell me the direction.
It's at the top.
At the top. Oh, yes. Yep, parallel to Stewart. All of these are parallel. All of these are parallel. See any others? Bottom right, you're talking about this? Yep. All three of these are parallel to each other. You got Palisades, Crown, Nob Hill. Sorry, I can't draw a straight line apparently.
What about Rose Hill?
Rose Hill, where's that?
To the left, bottom left. It's over there.
This one? This road and this road? Yeah. Good. So things are parallel all around us. Obviously, apparently not at Trinity. What is it? Did I circle the wrong one for you?
No.
All right. So parallel lines are all around us. You are going to see a problem that will have a map overlined with it. You'll have to find parallel streets. Okay. We're going to talk about perpendicular, which we have before. The definition, perpendicular lines are lines that form right angles. So lines that form right angles. What did the symbol look like for parallel lines? Yeah, the upside down T is the symbol. And then your key fact, 4 right angles are formed. And I'll explain it to you. This was actually a question on your test review, and I did see quite a few get it wrong. We'll talk about it now. How many degrees is a straight angle? 180. So of this straight angle, we have this right angle box. So how many degrees is this portion of the 180? Is 90. What is 180 minus 90? 90. So that means this angle is also 90 degrees, even though there is not a box. Also, what relationship does this angle have with this angle? What do we call them? The two green.
Vertical.
They're called vertical. What do you know about the measure of vertical angles? They're the same. So then the measure of this angle is 90, which means the measure of this angle is 90. You can also think about it like this. How many degrees is a full 360? And 90 plus 90 plus 90 plus 90 is 360. Okay? So we're going to do the same thing we just did with parallel, but with perpendicular. You're going to find perpendicular roads on this. There's one really big one. What do we think? I-10 and 295. Do y'all know this fact? What direction does I-10 go? Goes west and east. It's okay. And then what direction does 295 go? North and south. So fun fact about life. Highways that end in an even number go east and west. Highways that end in an odd number go north and south. It's for you to know. So these are perpendicular to each other. Can we find other streets that are perpendicular? They don't necessarily have to fully cross. They might just make a T.
Ramona and
Yep, Ramona and Cahoon. Yep. 295 and Cahoon? Or are you saying I-10? I-10 and Cahoon. What else do we see?
Rockland Drive and Ramona. Right there, straight across from school.
So you got Ramona. What else?
Straight across from school.
I just can't hear you. Straight across from the school?
Rockland Drive.
It looks close, but I don't think that's the right angle.
Obtuse.
Yeah, it looks a little obtuse. A little obese. What else do we think?
Ingram.
Okay, Ingram. There's this one. There's Gordine, or what did you call
I
it?
don't know. I just trying to pronounce it.
It's probably right. I don't know. Siri. So I live near Youngerman Circle. Y'all know where Youngerman is?
Yeah,
It's like almost Orange Park. It's fine. Yeah, I know you know. It's spelled Young, and then E-R-M-A-N. But the Siri says Yun German instead of Youngerman. She calls it a German. It's very
I
funny.
live on Chaffee and it says Chaffee.
Chaffee. You would think that with the technology we have these days, they'd get it right, but
Trinity Christian Road.
Trinity Christian Road, where's that? And what?
That's the road.
Trinity Christian Road.
That's Trinity Church.
This?
Oh, Church Road.
All right, I could see that make a right angle. Can't draw it, apparently. Yeah, that's the back way. This is the front entrance. All right, so there's a ton, right? We agree? Like all of these intersections over here are all right angles. We didn't even mention all the ones up here with Stewart Avenue, but every single one of these is a perpendicular intersection. All right, so we're going to learn about one more type of lines. There are skew lines. That's a really weird word, yes? So they're really awkward lines. They have literally nothing in common. Okay, so if you look, I'll give you the official definition in a second. So these bright green lines are skew. They will, so don't write anything down yet. Two lines are skew if they do not intersect, so you want to write that down, and are not on the same plane. So they don't intersect, they'll never intersect, they're not on the same plane, they have nothing in common, they're just two weird lines. So that's why these two bright green lines are skew. You have one on the road, and then you have one on the top of the overpass, whatever you would call that. So, here you have this box. We're going to find skew lines off of this box. Just go ahead and pick a line, any line. You said DC? That's fine. So, what you're going to do, the easiest way to do this is we're going to name all of them. Skew lines are not on the same plane. So we're going to find the the plane that DC is a part of. So what I do is, it's a part of the top of the box, right? So that means none of these lines are skew because they're on the same plane. What other part of the box is DC a part of? So the top, and then what else? Yeah, the front of the box. It is also the side of the box. Okay, so anything that's not highlighted would technically be skew. So we would say AB. Okay, what? Not AB. What did we name?
C.
Sorry. All of my other classes chose AB or the first ones. That's fine. All right, so DC or CD. And what other line would be skew? FE, sure. Any of the ones that are not highlighted are skew. So you could say FE. What else could you say?
BF.
You could say BF. What else?
GF.
GF, yep. So we're just listing lines that are not on the same plane and that don't intersect with DC. We still haven't named them all. What else do we have? EH, good. I want to say there's one more. CG is a part of the side. EA, I think, is the last one. EA. Good, so skew have nothing in common. Are these two skew, the two I just highlighted? No. Are these two skew? Yes, okay. Because DH is a part of the front of the box and this side. What about, is it skew with this one? Yes, it is. All right, so skew. Last thing we talk about are parallel planes. Yep, you can flip. So parallel planes are planes that are parallel. Okay, you can write that in. Parallel planes are planes that are parallel. Pretty self-explanatory. So they'll never intersect. What in this picture would be parallel, do you think?
Stairs.
Yeah, the stairs. If they aren't parallel, then what do you think would happen?
Oh, you wouldn't be able to go up.
Yeah, you might. It'd be difficult. You trip, maybe hit one. So we're going to name parallel planes based off our picture. What would be parallel with the floor? What plane is parallel with the floor? The ceiling. What is parallel with this wall? The other wall. What is parallel with, if it's level, what's parallel with your table? Don't overthink it.
Ceiling.
You got ceiling, what else?
Floor.
The floor. Okay, so they should be parallel. So we're going to name parallel planes off this box. So you could name the sides, the left side and the right side, the front of the box, the back of the box. We're going to name the top and the bottom. Why do you think I would want to name those? They're already shaded for us. So we're going to name them. So we're going to name the top of the box first. So we're going to say plane. Whenever you name a plane, you use 3 letters. So give me 3 letters off the top of the box. Sure, A, B, C. Then how do I say plane ABC is parallel? What does that symbol look like? That 2 straight lines. 2 sticks, that's good. So plane ABC is parallel. Okay, we want to name the bottom.
HGF.
Sure. So plane HGF. You could say EFG, GHE, and so on. All right. So this is what a problem on your homework would look like. Think of each segment in the figure as part of a line. So lines never end, and lines you name with the arrows. So we're going to be naming all of these with arrows. Which lines or planes appear to fit the description? So we're going to do A, lines parallel to CD. So we got CD, containing point A. So whenever we name a line that's parallel to CD, it has to have point A through it. There might be one answer, there might be many. So what will be parallel with CD? AB. Do we see any others? Does that contain point A? FE is parallel, but it doesn't contain A. So that's the only one I see. Now we're going to name some that are skew. Skew. So CD is a part of the top of the box, and it's a part of the side of the box. So we can't name any of these sides because they'd be on the same plane as CD. So what other line could we name that contains point A? A what? AH, and then there's one more actually. And AG. So AH and then AG. What's the next one say? Perpendicular. Okay. So perpendicular mean they intersect and form 90. So we still want to contain point A. So what do we think the side would look like? AD. So we want it to be perpendicular to DC. AH would be perpendicular to HG.
Wait, CB?
I think that's the only answer. It still needs to contain point A. CB would be perpendicular, but it doesn't contain point A. So then just AD. All right, last one is parallel. We're going to name parallel planes. So it gave me FGH, or EFG, sorry. That's the bottom plane. So that means it'd be parallel to the top. Before I name a plane, what should I write? Plane. And then pick 3 letters from the top. CDA, sure. All right, we flip. This is what I meant by you have a map. The given line markings show how the roads in a town are related to one another. Name a pair of parallel lines, name a pair of perpendicular, and then asks a question. So whenever we're naming parallel lines, what do I want to be looking for in the picture? What symbol should I be looking for? Little arrows or little triangles. So I see some here and here. So that means that these 2 lines are parallel to each other. Okay, so I highlight them in purple. So all we need to do is name them. How would I name this first line? I can't say line D. You could still name it a line. We're gonna name all lines. DM. So A, you were fooled like I was at 8 a.m. this morning. A is actually not on the line. The dot's over here. It's okay. That's a trick. Such trickery. So we got DM is parallel to, so you use the symbols. And then how would we name the other line? EF. Good. So those are our parallel lines. We're going to find perpendicular lines. What would I look for in this picture to find perpendicular lines? A right angle. So I'm going to outline the 2 streets that sit on that right angle. We can name the long one first. How would I name this street? Yeah, you could say BF. What else could I name it? You could say what? BM, yep. MB, FM, MF. I think that's pretty much all of them. And it is perpendicular to, we're going to name the other line going the other way, which we've already named. So what do you name it? DM. All right, and then the last thing is answer the question. Is FE parallel to AC? So FE parallel to AC, I agree. It would be a no, but you also need to explain. There's 2 reasons why. Okay, they'll intersect. There's another reason. So they'll intersect. Good. And they don't have the parallel. I'm very sorry.
Can I move it after class?
After class is fine. I wondered who it was. All right, and then they don't have the little triangles. There's 2 reasons. They'll for sure intersect if this line keeps going, and then they don't have the little triangles. All right, we flip. This is where we're going to use our highlighters. We're going to learn one more thing. So, you're going to see at the top of the page it says transversal. It sounds like a really weird word. It sounds like a hard concept. But actually, it's the name of a line. So what you're going to put, a transversal, is just a line that intersects 2 or more lines. So it's a line that intersects two or more lines. A line that intersects two or more lines. Alright, so we're going to talk about it. You don't have this picture on your page, but that's fine. Well, yours kind of looks like this, yeah? Yeah, it looks like that. So before we go any further, you're actually going to label yours. All of them should have 1, 2, 3, 4, 5, 6, 7, 8. So I'll give you a second to do that. 1, 2, 3, 4, 5, 6, 7, 8. Make sure it matches mine, or it will be too confusing for you. So 1, 2, 3, 4, 5, 6, 7, 8. So you want all of them labeled like that. I just don't think the desk is level.
I think it's the hinges or something.
Yeah. Yep, so you're naming the angles 1, 2, 3, 4, 5, 6, 7, 8. Alright, so the transversal is the one line that cuts through two lines. So this will be like the classic picture you'll see. This is what we call the transversal. Your transversal could also be sideways like this. Okay, so what do you think the transversal is? Is it a line going up and down or a line going side to side? Side to side. It's the one line that goes through two lines. That's all it is. So because of a transversal, there are going to be relationships formed. You see them. There are 6 of them. 2 of them you've already learned before. What 2 on this page have you already learned before? Vertical angles and a linear pair. You've already learned them. We're going to review those tomorrow. We're not going to review them today. Okay, we'll do the others. First one is a corresponding angle. You're going to go ahead and write in. There are 2 angles that occupy corresponding positions. You just write in the box. So 2 angles that occupy corresponding positions. And then I'm going to list them. I'll show you how to color it on your paper. One person didn't follow directions, so his notes looked absolutely useless for any help in the future. So just make sure you follow with what I'm doing so you can color code correctly. Corresponding angles occupy the same spot. So here's what that means. There are 2 intersections, right, where 2 lines come together or cross. So basically what will happen, corresponding angles have the same spot at their intersection. So this top left angle will correspond with this top left angle, and so on and so forth. So what you're going to do with your highlighter, I'm going to list them. I'll show you what to do. Angle 1 and angle 5 are corresponding. So with one color, I would color the arc of the top left. 1 and 5 are corresponding because they are both in the top left. That was a very funny place to leave highlighters. They're both in the top left. It was Terrell. He just had it in his jacket. No, right here. You did it. All right, so then you keep going. So you got 1 and 5, 2 and 6. So again, with a different color. All right, so 1 and 5, 2 and 6. What do you think is next? 3 and 7. So again, with a different color. All right, and then last one, 4 and 8. So they're corresponding because they're in the same spot. So top left, top right, bottom left, bottom right. So they're corresponding. Okay, so that's the first relationship. It's a circle. Yes, it will be. Next one we're going to talk about is alternate exterior. So you're actually going to go down a box. So make sure you go to alternate exterior. When you think of alternating, what do you think of? Switching, okay. Going back and forth, that's good. And then exterior, you think of outside. So here is what's going to happen. Alternate exterior, angles. You don't have to write down the whole thing. Here's what I would write. They're obviously two angles, but they're outside of the double lines and on opposite sides of the transversal. And I'll explain it. I'll show it to you. So they are outside of the double lines and on opposite sides of the transversal. So here's how you figure out what's outside and what's inside. So if you see it says outside of the double lines, here's what I always tell people to do. I always connect the double lines so that you can see a box. So would you guess that 3, 4, 5, and 6 are outside the box or inside of the box? They're inside. So this would be called the interior. So all of this is the exterior. Okay, all of these 4 angles. All right, so number 1, they're going to be on the outside of the double lines, and they're going to be on opposite sides of the transversal. So with your first color, I would highlight this angle. The angle that is alternate exterior with 1, okay, so exterior means it has to be on the outside of the transversal, and it's going to be alternating on the opposite side of the transversal. So remember, this is your transversal. So your alternate exterior is this angle. I believe it's angle 8 on your picture, yeah? Yeah. So angle 1 and angle 8. I think mine will pop up. 1 and 8. So then 2 and 7 will be alternate exterior. Okay, so they're on the outside of the double lines, and then they're on opposite sides of the transversal. 1 is on the left, 8 is on the right. That kind of thing. I show you this picture to show you that it could be up and it could be looking a little differently, but the same property stands. Whoop. If you connected the 2 double lines, this would be inside. So what would be alternate exterior with 1? 8, and then 3 and 6. Okay, so it still counts even if it's turned weird. All right, now we're going to do alternate interior. It has the same exact definition, except for what do you think is different? It's inside of the double lines. So they're inside the double lines and opposite of the transversal. So that's in the top right box. So inside the double lines and opposite and on opposite sides of the transversal. Sorry, I had decided this morning that we would do those last 2 tomorrow. So. All right, so again, inside means inside of these double lines. Okay, so first one's going to be 3 and 6. Good. 3 and 6. So in one color, and then 4 and 5 in the other. So the interior are easier to see that they're alternating because they're across from each other. All right, the last one is consecutive. When you think of consecutive, you think of what? You think of what? Multiple, continuous. If you said, we used to, it's unfortunately, we used to have consecutive championships.
Oh, yeah.
So what did that mean?
Back
Back to back. Okay, so consecutive interior, where do you think these angles are going to be? Side by side and on the inside of the double lines. So what's going to happen? They're inside of the double lines and on the same side of the transversal. So they're on the inside of the double lines and on the same side of the transversal. So it'll be on the inside, but then on the same side of the transversal. Remember that the transversal is this line that's going down the middle. Okay? So, it's going to be 3 and, what is this, 5? So they're both on the left side of the transversal. So 3 and 5, and then obviously 4 and 6. Okay, so 3 and 5, 4 and 6 are consecutive. All right, so again, we're going to skip vertical and linear till tomorrow. We're going to do the bottom. So if you look at how mine is set up at the bottom, you're going to be listing all of the angles that are corresponding, all the angles that are alternate interior, etc. So I put A, B, C, and D at the bottom because there's not really enough room. If you don't want to do that, you don't have to, but you do you. So the first thing we're going to do is corresponding. Corresponding mean they're on the same position at their intersection. So angle 1, we'll start with that. When we name an angle, we always have the angle symbol and then the number. So angle 1 is in the top left. So what angle is in the top left of the other intersection? Angle 5. So angle 1 and angle 5 are corresponding. So we're at the bottom. Angle 2 is in the top right. So angle 6. So angle 2 and angle 6. Angle 3 is in the bottom left. So angle 7. And then angle 4 and angle 8. Good. This next one asks for alternate interior. So it needs to be inside the double lines. And then alternating across the transversal. Go ahead and label that this is your transversal. Because remember, your transversal is one line that cuts through two lines. Slash highlighted in blue for you. So we need them to be inside of the double lines and on opposite sides of the transversal. So what is 2 is the first one. It's inside. What is it opposite sides of the transversal with? 7. So 2 and 7. 4 and 5. Again, because they're inside and on opposite sides of the transversal. Next one's alternate exterior. So they need to be on the outside of the box and then alternating across the transversal. So 1 and 8. So 1 and 8. And then 3 and 6. The last one is consecutive interior. So this is still your transversal going down the middle. So consecutive means they're on the same side of the transversal. So this time the transversal is a horizontal line. So there's above the transversal and there's below the transversal. So we got 2. What is 2 consecutive with, do you think? It is 5. 2 and 5. 4 and 7. 2 and 5, 4 and 7. Two and 5, 4 and 7. We'll end there. You do need out a sheet of paper. I'm going to make you write down today's homework only because the internet apparently has been, the website doesn't cooperate with the new iOS system with Apple, shockingly. I don't care if you don't have an Apple. I just want you to make sure an Apple. An iPhone. Just make sure you write it down. You do need to copy the diagrams once. I think there's 4. This is 9 total problems. Just 9. That's all I'm asking for.